Welcome back to Biomindscape. Today we are going to know about the equilibrium theory of island biogeography. Now first we will know what is a biogeography. Biogeography means it is a study of geographical distribution of species and the reason for the pattern of distribution. So there were two ecologists, namely Robert M. MacArthur and E.O. Wilson. Now these both these author were present. So this author proposed the equilibrium theory of island biogeography, and according to this theory, level of species diversity on habitat island, the level of species and the diversity on an habitat island, it arises a balance between the process of colonization, that is eye migration, and extinction of species. Now what is an eye migration? Eye migration means is one mainland, and from that mainland the species is traveling from one place to the island area where there is no livelihood or some, it is very away from the mainland, so that is eye migration. And what is extinction? The existing species that is degrading, that is totally vanishing from that particular place, so that is extinction of species. So what is an island? It can be formed, what the island can be formed by ocean island, like it can be habitat or which is totally separated from one of the mainlands, so it can be considered as an island. So it can be caused by volcanic eruptions or many various factors. So the ocean island, it can be formed by two basic way: by disappearance of the connecting land from the mainland, that is by why it is happening because of the sea rise or floods on an area, or in if joining land is eroded or sinked, or by the land rising from the sea, usually from the volcanic activity on an ocean flood. Gradually they build up the igneous material until it reach above the sea level. So because of that, the island is formed. So the number of species found on an island, according to MacArthur and Wilson, it was due to two processes. First is eye migration and extinction. Now we know that eye migration, what is it, and extinction, what is it. So the theory proposed that the number of species of an island, it is determined by the balance between the rate at which new species is colonized, that is the rate of high migration of species from the mainland to the island, and the rate at which the population is establishing species become extinct, the rate of extinction of the species on an island. So rate at which the species might become extinct on the island would be related to the number of if that have been resident. So when an island is nearly empty, when there is no uh, species on an island, that is it is empty, so the extinction rate is necessarily low because few species they are available to become extinct. So as more species inhabit an island, extinction rate on the island increases because of the greatest likelihood of competitive exclusion. So at the same time, as the number of species of island increases, and migration rate of the new species decreases. Hence the rate at which the additional species reside in a population, it go extinct and will be higher. And when the island is relatively full, over time the countervailing forces of the extinction and migration result in equilibrium level of species richness. So equilibrium species richness of an island at which the migration balance the extinction and which remain roughly constant, and the number of species in a community, not the identity of the species involved. So here we can see the theory of island biogeography state the number of species of a given taxa like insect, bird and mammal. They are present on an island within a patch represent a dynamic equilibrium between the rate of high migration of new colonized species of the taxa and the rate of extinction of previous established species. So equilibrium number of species of island represent a balance between the migration of new species and extinction of species that already existed. So, according to the theory of island biogeography, our migration rate declines as there is increase in the species richness, with extinction rate increasing. So, two physical features of island further affect the migration and extinction. It's the size and distance. So, two physical features of island further affect the eye migration and extinction rate. So, its size and the distance from the mainland, and the mainland is that place where the new eye migration species originally inhabit. So, first is the effect of size and effect. The second is effect of distance. So, it is well established that the number of species on an island it decreases as the area of that island decreases. If there is a smaller island, it will have higher extinction rate because it have few resources and less diverse habitat for colonization of that particular species. So if there is a larger island, there will be reduced the probability of extinction because there is a large number of habitat area and the resources are more for colonization of the particular species. So, lower the rate of extinction on a larger island, it will result in higher equilibrium number of species as compared to the small island. The second is the effect of distance, where the expected number of species of an island it is affected by the area of island and the distance of an island for that source of species. Like island that are more isolated, they are having less likely to have eye migrant than island that are less isolated. So the greater the distance between the island and the mainland, the lesser will be the likelihood that many eye migrant will successfully complete the journey. So it results in decrease in the equilibrium number of species. So two islands of equal size, as an island close to the mainland generally has higher eye migration rate than the one that is far away. So here we can see two graphs that shows the effect of island size, where the large island have larger equilibrium number of species than that of the small island because there is higher extinction rate will be lower on larger island, and the effect of distribution here we can see in this graph from the mainland near the island it will have tend to have larger equilibrium number of species than the far island because eye migration rate to the near island we can see it is higher. So if island is closer to the mainland, it will be easy for species to reach the species and they will arrive quickly. So the e-migrant rate will be very high, and if the island is far from the mainland, then fewer species will reach it and rate of eye migration will be much lower.